In this section, we discuss two additional statistical methods that can be used when randomization is not possible. They are differences in differences and discontinuity. These methods are a bit more complicated than randomization, technically, but they make designing the study easier in practice. There are several more, even more complicated statistical methods that we won't cover here, but these methods are among the most common. Differences in differences. In contrast to randomized control trials, we do not randomize who participates in a program and who does not. Instead, we relax our assumption that the control and treatment groups are the same on average. To clarify, instead of referring to the control and treatment groups, we'll refer to comparison and treatment groups when randomization is not used. It's important for the comparison group to meet one important criterion. The comparison group should react to economic and environmental shocks in a similar way as the treatment group. Average characteristics in the two groups can, however, differ. Let's go over an example. Imagine a program that provides mosquito bed nets to decrease the incidence of malaria, and that there are 2 villages. In reality, a study would likely involve more than 2 villages, but we'll just keep it to 2 to make this example easier to understand. Village A is poorer on average than Village B. Therefore, Village B is selected. However, both villages are in the same area and they experience the same weather. They're also economically similar enough that if there is a change in the price of goods bought and sold by residents of 2 villages, then residents of both villages will be affected similarly. Also, both villages should be affected by government programs in a similar way. If this is the case, then we can assume that both villages will react to changes in environment, economy, and society similarly. So, if incomes in Village A go up, then there should be a similar effect in Village B as well. This is true even if the average income in both villages is different. Then, if a program is introduced in Village A but not in Village B, we can estimate the effect of the program as long as we have data from both villages both before and after the program. Any change that is observed in Village A that is not observed in Village B can be attributed to the program. This table sums it up. We collect 4 sets of data, that is, in each village, both before and after the program has taken place. The effect of the treatment is then the difference between outcomes before and after the program in the treatment village minus the difference in outcomes before and after the program in the comparison village. This means that we take the total change in the treatment group, which includes both changes due to the program and other unrelated changes, and we subtract the changes in the comparison group. If we do that, then what we're left with is the effects of the program itself. This graph may make things easier to see. Before the program, the average outcome in the treatment and control groups are not the same. After the program, the outcome has gone down for both groups. However, as you can see, the difference between the treatment and comparison group is smaller than it was before the program. So, with our example of mosquito nets and malaria, rates of malaria are lower in the comparison group than in the treatment group before the program. After the program, malaria has gone down in both villages. Now, this may be because of improved economic conditions in both villages. Possibly the prevalence of malarial mosquitoes has dropped in the area due to environmental conditions. The point is that this has happened in both villages. The change in malaria rates in the comparison group gives us an idea what would have happened in the treatment group if we didn't have the program. This allows us to estimate the effect of the treatment. All of this depends on the assumption that both groups really do react the same way to changes. This means that the comparison group should be selected with care. If historical data is available, it's a good idea to confirm that even if average levels of income and health are different, that changes are similar across time. Let's go over another example. Farmer field schools may be implemented in one county, but not a nearby one. Assuming that weather is similar in each county, as are changes in prices, then using data from each region before and after the program should produce a reliable estimate of the true effects of that program. If you have historical data on crop yields, you can check to make sure that this is the case. Be careful, since major events like floods or storms that may occur in the comparison area but not in the treatment area, or vice versa, could seriously bias estimates. One last example. Consider a healthcare program that is implemented in one district but not in a neighboring one. Depending on the disease that we're interested in studying, this may or may not be a good candidate for diff and diff. Some diseases, like cholera for example, break out locally. This makes it likely that changes in each area will be quite different. With malaria, on the other hand, diff and diff might make sense, since malaria incidence is more stable from year to year and from village to village. Again, historical data can help to sort this out. We'll cover the second method in this section, discontinuity, much more briefly, as it's relatively simple. The basic idea is that while assignment to the treatment group is not random, there is a certain range for which the selection criteria does not significantly influence the outcome variable. For example, let's say that there's a training program that's only open to people under 25 years old. Now, 30 and 20-year-olds will differ in many ways, and comparing them is not a good idea. However, those just above and just below the threshold should be very similar. We can compare 24-year-olds and 25-year-olds both before and after the program, and then estimate the effects of the program. In other words, the people just below the program threshold are, in this case, the treatment group, and the people just above the threshold will be our comparison group. There are a couple major problems with this approach. First off, the administrator must hold the threshold strictly. If exceptions are made, especially if they are non-random, then this method will no longer be applicable. These estimates, secondly, only apply to individuals who are around the threshold. In our example, our estimate would not be applicable for 20-year-olds in the program, for example. The purpose of this section was to briefly introduce you to a couple of ways of conducting a program evaluation that do not require randomization. For more on this topic, see the section on data analysis.